Hi, this is Thomas from Apex Game Tools. In this video we're going to look at request preprocessors. A request preprocessor allows you to modify a path request before it reaches the pathfinder. So this allows you to set up certain requirements that you want your units to uphold, and then modify the request so that they meet these requirements. Before we get to look at the code and how you implement these preprocessors, I'm just going to show you this example. So in this scene, I have a unit, as you can see in my top right corner, and I've defined a few safe havens in my scene, these green spots. And the requirement is that units can only move to safe havens. So the unit will not be allowed, or should not be allowed, to move to cells that are not green. And this is accomplished by a preprocessor. So when I select my unit and I select some destination that is not green, it will move to the nearest green. Now it actually doesn't move in this case to the nearest green cell, but that is because we are using this simple implementation, and I'll get back to the specifics of the implementations after we have looked at the general implementation. So this is the setup. So now let's have a look at how you implement these. What you want to do is you want to implement the interface called iRequestPreProcessor. You also want to implement it on a class that is a mono behavior, because you need to attach this to the game world so that it can be picked up by the Pathfinder when it starts. The iRequestPreProcessor interface has one property and one method. The property is the priority. This means that preprocessors with a high priority will be executed before preprocessors with a low priority. So if you have multiple preprocessors attached, they will be executed in that order, high priority to low priority. And then we have the method that you need to implement. It's called preprocess. It takes the path request as its only argument, and it returns either true or false. How it works is that it will process all preprocessors in the order of priority until the first one that returns true. Typically you would want to return true if you modify the request in any way, but of course you can return false in all cases, and then allow all the preprocessors to have a go at the path request. So that's all there is to it. That's how you implement a request preprocessor. Now for the rest of this video we are going to look at the specific implementations of this particular use case, and we will also be looking at one of the utility classes that you have available that allow you to evaluate the grid in a more advanced way than what you just saw before. But let's start with this simple version, which is the one I just showed you in the example. So what it does in its preprocess method is that it will look initially at the goal, that is where you clicked, to see if the goal is actually safe. So if you already clicked in a green spot, then obviously you are allowed to go there. If that is the case, it has nothing more to do, so it returns false. It will not modify the request in any way. And next up, if this is not the case, it will then start looking at neighbors to the goal, and it will look at them. In this case, in the simple model, it will look at concentric neighbors. This means that it will start by looking at the immediate neighbors, the 8 neighbors of the goal cell. If none of those meet the requirements, it will then look at the next level of the layers, if you think onion, and then it will just expand and expand and expand until it finds a match. So the first match it finds, it will then assign that as the new request's destination, request 2, and then it will return true because it has modified the request. So we just saw that in action on an empty scene, and as we saw, while it actually works, it doesn't actually pick the closest You would probably have expected it to pick this cell because that is actually the closest one to where we clicked, but it just so happens that it takes this one because when you expand like an onion from here, the first cell that it will actually meet that matches the requirements will be this one up here. Similarly, the simple approach has some other problems. If, for instance, we enclose one of our safe zones in walls so we cannot actually not reach it, then when I click here, it will still actually attempt to reach this one because it doesn't really look at whether or not you have access to this safe zone. And similarly, if we do like this, well, this may or may not be what you would want, but if I click down here, it will move up here because this is still the closest green spot to this point, but it is also on the other side of the wall to where the goal was. So how can we improve that? Well, we can use a utility class that does a slightly better job. So let's just see that in action first, and then I'll show you how that is implemented. So if instead we enable this advanced model, again with a blank scene, as you can see now it actually picks the closest one as we expected. Also, if we do like before and we put this into a wall and I click here, it is actually going to pick this one because this is the only one you can actually reach, the closest one to this point here. And it will act the same way if we take this path here, the wall section here, and I'll click here and it will pick this one down here. That is because this green spot down here is the closest reachable spot seen from the original destination. So how do we achieve that? Let's have a look at the advanced instead. This makes use of a utility class that has been included with ApexPath called Grid Evaluator Closest Match. Now this in itself is just a utility class that you can alter or create your own based on this if you want some slightly different way of evaluating closest matches. But what this one does is it will simply evaluate cells and take into account whatever extra criteria that you set up in addition to whether or not it is a match to, in this case, the requirement of being a safe zone. So the first part of the preprocessor is completely identical to the simple version. It starts by looking at the initial goal. If that meets the requirements, obviously there's nothing more to do. If it does not, it will instead use this evaluator to find the closest cell that actually does match. Now this method here, it takes a few additional arguments. It takes the grid that it needs to look at. It takes the start destination from where to look. In this case, that is our destination, the original request to. And then it takes two methods. One is the same as the one we use to evaluate whether it's safe. This is the match method. All the cells that meet these requirements will be, the one returned here will meet this requirement. And then we have a discard method. I can just show you the actual signature. So we have a match method and then we have a discard method. The discard method works in the way that it will then discard cells when it evaluates neighbors of a given cell. It will discard all the neighbors that meet this requirement and not expand further from there. In our case, since we actually have we need to evaluate some of what we're doing here in the context of the unit navigating, So instead of having methods on this class itself that we passed in here as the delegates, I've created a small struct down here to encapsulate this data. So this is just a very simple struct that has the unit properties on it so that we can evaluate in reference to this unit. And what it does is simply it says the same as before. If it's safe, it looks at the safe havens and sees if the position evaluated is safe. And is it blocked? That is the discard function. And it simply looks at whether or not the cell is walkable to the unit. This means that it will discard all cells that are blocked by obstacles. It will not expand further from them. So that is how that's implemented. And you can use this, obviously you don't need to use this only in relation to request PreProcessors. You can basically use this utility class to evaluate the grid to find cells that meet certain requirements. The closest cells in this case that meet certain requirements. So that was it for request PreProcessors. See you in the next video.